So first of all, thanks to ONF team for giving us an opportunity to present our thoughts on this platform. So today's talk would mostly focused on to understanding what are those next generation RAN requirements that would lead us towards 5G and ecosystem building perspective. And Sterlite is actually targeting from an ecosystem perspective, most of the ecosystem points and the solution to integrate them, and we call them as pods. So we're going to see what pods mean and how they can bring value to certain challenges that are faced in the domain of RAN and 5G. Okay. So just a quick cap, the agenda for this talk. I'll have a quick introduction about my company. Requirements, which is the most important part of this talk. How STL sees these requirements can satisfy, and what is the path to address those requirements. What is our approach, and what benefits could be brought on through this approach. Some use cases that we think that could help bringing industry to a pace where 5G and the other technologies can bring the value at more pace. And then we can have a quick question and answer session. Okay. So a quick introduction. Sterlite technology has a global presence in 100+ countries. When I say that, these are not just the post office box addresses. We have market presence, sales office, manufacturing locations, development centers across different geographies. And we are centered, headquartered in India, Pune as a city location. So just a quick cap, Sterlite technology basically has 3 business units. First one is the products. So we build fiber optics products. So basically manufacturing the fiber cables right from procuring the silicon, processing, making the glass, and then making into the optical fiber cables. That's the first business that we have. Second one is the SI, the system integration services. We are building networks in a lot of countries, and we are partnering with the local vendors wherever those challenges that we see. We are bringing partners on board and providing the network deployments for those geographies. And the third one is the software business. So this is primarily an OSS, BSS software that we are developing. And for past 1.5 to 2 years back, we have started a group called Programmable Networking and Intelligence, which I'm part of. So we call it as PNI. And this group is pretty much focused on to SDN and NFV technologies and bringing the solutions out of this. Okay, so let's jump on to our main topic. What are those requirements that we think will drive the next decade? Because history is always thought in terms of decades. That's where the actual changes can be realized. Others could be a little noise within the decade. So here we want to focus on what are our key enablers for these requirements. We understand that 65 to 70% of the total cost of the ownership is usually into the RAN, into the telco networks. The second one is the SDN and NFV as in technology has done a lot of things, a lot of brainstorming has been done in core, but RAN has usually been untouched till now, at least till recent past. So that's one of the key enabler for us to think into this direction, what best we can do in this area. The third one is the open interface, which we are all here about. We want to see those open interfaces really getting deployed into the carrier-grade systems, bringing those multi-vendor deployment opportunities coming into picture playing a good, vibrant supplier ecosystem role. The fourth one is obvious that since the traffic is growing maybe 1,000 times percentage-wise, the network is becoming complex, and this is the time where network has to self-realize that it has to manage itself, it has to automate all those operational entities, maybe through AI and ML kind of deployments. So those are four key enablers we think that important to look into this perspective. Some additional things from an RAN requirements perspective. We need to see those the multiple access technology are getting converged, bringing 5G networks into the realization. So this has to happen swiftly, probably in a more flexible way. From a hardware perspective, to get onto a vendor locking perspective, the more open the hardware would be, the more opportunities for the SDN kind of technology to come into the picture and deliver the value. Then there are aspects of scaling, high availability, and security. Those was obviously coming into the picture. The reason being the kind of network, the kind of network state, the kind of network traffic that we are seeing. We need to scale our solutions independent of the services or independent of the specific deployments. So it has to be flexible as well. And at the same time, we want to ensure that our platforms are diversified so they can address not only outdoor kind of deployments, but there has to be an indoor as well. So that's why the enterprise to the career class, where we say that 5 nines is what career class defines. So when I'm saying that 5 nines is what career class is defining, how best my platform is ensuring that I'm able to deliver that kind of availability. And the last one is you don't want to just scale control plane along with user plane. If your user plane can independently scale, that's an awesome thing to do. But that's where we should move at this moment. So those are some of the requirements those we think will mean much when we talk about the 5G and ecosystem. Well, this is, everybody knows, now the boxes are getting moved to the functions, a virtual function or a container-based function. Our proprietary protocols are getting moved to the open APIs. And for any successful innovation in any domain, you could definitely focus on to what exactly your application would do, what is the core service that it has to provide. But then in this era, it has to go to the cloud native to ensure that it succeeds in the ecosystem. And that's why these are the two of the important properties of a cloud native solution. There are others, but these are some of the key things that one should think about. Okay. Along with this, we all know that IMT 2020 vision has given us three three requirements. And definitely all these three requirements would drive certain set of requirements in RAN. And we cannot just ignore these three important definitions. Okay, sorry about that. Okay, so what are we going to do with STL's approach? So we at STL thinks that for any successful 5G implementation, you have to have a RAN or a radio implementation which ensures that those requirements are met. The packet core has to be the standards compliant, and you should think of edge cloud. Well, we know that nobody knows where edge is. It's architecturally dependent concept that where you want to realize your edge in terms of your use cases, in terms of your deployment scenarios. So those are some of the important aspects. If we are targeting at least these 4 points, I think a particular operator or vendor is in right direction to tackle to the 5G scenarios. And what we are trying to do is we are building a platform where the distributed 5G networks can be hosted. Multiple of the access technologies can be federated. When we talk about intelligence, all your observability through the different monitoring entities, those could be sensors or those could be IoT-based devices. If you can feed this data stream all the way up, maybe from RAN to your RIC controller to the orchestrator, and if you could feed it to the AI/ML engine, those are the real values can be delivered from there when they can deliver the trained model to your controller, and controller can actually convert those models into the policies, and those policies could be actually implemented onto your network elements. And obviously, we want to ensure that our architecture is ORAN compliant. So there are E1, E2, and O1A1 interfaces which are getting in shape. So we want to ensure that that aspect is also addressed. So that's STL's approach. So let's see what STL has brought. So POD stands for programmable. We see that down the line when we do the SDN, we utilize the P4 as a programming language and Stratum as NOS. We are doing a lot of open source initiatives and projects which are kind of core to our products and solutions. We're working very closely with ONF, TIP. From an orchestrator perspective, we also work with ONAP and ORAN, as I've already mentioned, that these are the interfaces that we want to work. So that's openness. And what does it mean for disaggregation? So we already have thought about disaggregation in perspective of having a lot of partners where we think that their skills or their expertise can be brought into our solution. And that's why we are collaborating with some of the partners, SOX as our RAN partner, supplying BBU or CUDU, Fujitsu as radio, VMware and Red Hat as the NFVI layer, and STL has its own some of the components. So that's a disaggregation for us. And from a solution perspective, there are a lot of solutions, but at this moment, Sterlite is looking onto the private LTE part and 5G and our programmable radio. So that's a POD's definition for us. That's what we realize when we talk about the PODs. Okay. So let's talk about what are the disaggregation goals, those we want to see when we are talking about the solution. So disaggregation has to put operators in control, and ONF is very well giving that opportunity to operator to define those requirements, and we as the products and solution creators are taking those requirements to ensure our products have those. Democratization of the interfaces for plug-and-play modules. When we say that, I have seen implementations which are not large scale, but they are the population scale that I'm talking about. And that's where the architecture plays a very critical role, that if your architecture is designed in such a way that your open interfaces allows any of the architectural component which could go obsolete if you're using open source, that can be very easily plugged back or replaced. And that's why this second aspect is very, very important. Your disaggregation has to allow you to deployable for any ARPU models. I was talking to one of the attendee here, and the experience was in one of the country, the ARPU was kind of $2, and the target was to get into $1 per month. So your solution has to go for ensure that these kind of things are met. Well, this is courtesy ONF, but I like this pretty much from a conceptual perspective. The disaggregation has to go with open source onto the white boxes. At the same time, your disaggregation should allow the different kind of configuration in your solutions. Those are your solutions have to be deployed into ruler or into densified deployment models. You should be able to cater to milliseconds control loops. When I say that, when we talk about the RAN, I see them. There are at a high level there are 3 control loops. First one is probably 1 to 5 millisecond, where probably your MAC layer sits. And then 5 to 10 milliseconds is the another control loop, and then 10 to 50 milliseconds. So these are some of the control loops which your solution should address. Containerization and microservices-based architecture will definitely going to help us in realizing these things. So these are some of the disaggregation goals that we have come along with. And then from a programmability perspective, we know all this standard stack where we talk, all these talks have been giving us information. So there are control messages for each layers, and there are measurements that has to be done onto a particular layer. But then we really think about what are those core utility important functionalities of those layers, and if we can bring in some of those important function to a controller, let's say for example handoff management, if we can bring it to the controller layer, then I think we can do the things in a better way. So that's about programmability. That's what we think here. So from an actual realization perspective, edge cloud is the area where we think that our solution can be realized. We want to disaggregate and virtualize some part of the wireless RAN, put it into the edge cloud, some part of the EPC, and get it into the RAN. That's about, and this is what our pod looks like actually. It is a programmable radio pod, which has essentially all the aspects of RAN. This is RU-DU, and then CPRI-based interfaces, CU, and then RIC and orchestration. So this is kind of a pod that can be deployed onto the edge side. Some of the key highlights are we have already partnered with vendors for RU and CU-DU. Our RIC development has already started. We have some of the use cases to target. From a VNF or NFVI platform perspective, as I said, the Red Hat and VMware, these are the 2 of the vendors that we are looking for. And we think that if this complete integration, we should be able to target in probably years down the line. Okay. So this is the pod, and how I just wanted to put this picture. So from an architectural perspective, how could this whole architecture gets fit into this? So this is primarily kind of an ORAN-based architecture where you see that the RU is at the down layer, and you have the NFVI virtualization layer, which is hosting your CU and DU part. E1 is the interface which you usually have between control plane, CU CP and CU UP. And E2 is an interface which you basically put onto a RIC and CU. So at this moment, we are pretty much focused onto this layer. We are working onto the RIC controller. We have realized this RIC controller in terms of implementing one of the use case, which is a handoff management use case. There is already a radio nib storage that gets the live network state information and stores into the radio nib, and the handoff application actually utilizes this radio nib store. Okay. So from a benefits perspective, we see that if we can bring in this kind of solution, the real-time programmability can be achieved. When we say that this could be from a trained model which are coming from the AI and ML could actually transform into the policies and can be pushed down to the network elements. We are building a lot of applications which could do the reconfiguration of those logical nodes. When we say that you have a virtualized CU and DU, and if you want to scale in, scale out, those are the things, those can be done easily here. Okay. Okay, so this is, so what this tree gives an information is, from a functional perspective, we want to break down each of the key feature into the sub-functions, and then those sub-functions can be actually implemented into the microservice-based architecture. And that, so I'll not go through all of these, but the thought process here is we are actually breaking all the features into the functions and sub-functions so that those can be directly mapped onto the container-based applications. And that's where the scaling in, scaling out kind of advantages we could get. Okay. These are some of the measurement entities that we think are very important from an user's experience perspective. Heat maps, let's say consider per slice heat map. So heat map is basically gives you an information where exactly, what is the region or what is that area where exactly your users are either using it too much or it's average or it's low. So those kind of measurements would help us bringing the true AI and ML intelligence into these solutions, because once we have all this data coming from the lower layers, we can do at least these 5 aspects in a better way to ensure that your customer's user experience is matched. Okay. So quickly from a use case perspective, as I said, handoff management is one use case that we have implemented. There are 3 more use cases which we think that which are the priority for us to realize. So I'll just talk about the handoff management quickly here. So we see handoff management into 2 aspects. One is the handoff for better quality of service experience, and another is the load balancing amongst the eNode Bs. So like in the last talk, I was mentioned that CQI value or channel quality indicator is one parameter that can be used into the handoff for better quality of service, and that's what exactly we have also implemented in one of our demonstration. The another aspect of this is load balancing can be triggered when you have a real-time or near real-time state information for you. Then you could have all this kind of parameters. Maybe it's total transmit power, total receive power. Some of the critical parameters can be used to see that the eNode B, particular eNode B is loaded, and it needs load balancing either through handoff or some more mechanisms. And that's what handoff is. Okay? So from a Sterlite perspective, we are focused on offering our dynamic configurations and real-time programmability as a characteristic. We don't have, and we don't want to go with a particular hardware. We are pretty much compliant with the OCP hardware vendors. Our architecture perspective is this split architecture. When we talk about RAN, it is 7:2 split architecture. We are building the platform to ensure that the containerization and packaging is something which is integral to our platform, and automation and ML is also an important entity for each of our solutions. So this is kind of at least an image where a pod would look like. You would have all the important parts of solution in a pod. Yep. Okay. So I think I'm done with my talk, and if you have any questions, you can ask there. Yeah.
Okay. No.
Well, you can visit us at ONF booth where the software-defined RAN is, and we are running a demo over there that you can go through.
Yeah, we can go to look at the booth. There's a live demo there.
Okay.
Thank you, Amit.
Thank you.